In this video, we're going to talk about exponential functions in tables of values. After this video lesson, you will be able to identify exponential functions given a table and describe that rate of change. A local reservoir has a population of microbacteria. When the bacteria count gets too high, over 5,000, it is too dangerous to swim and the beach is closed. The population of microbacteria starts at 10 and triples every day. So this starts at 10, which we see right here. This is our starting value. And the other piece of information that's really key here is that it triples. We haven't had any tables that triple, and we'll talk about how we see that as we go through this. When we're talking about identifying any type of function with the table, we always want to start with our change in x and our change in y. So you are going to do that now. Just go down the table and find your changes. So in our table, we see that the change in x is 1, and the change in y's are all different. These are all different. So it's saying, what do you notice about the change in y and the values? Let's write some of the things that we notice. They are only increasing. So for a quadratic and for an absolute value, when we're seeing these, we're seeing a turning point. And if I look at my y values, I don't have a turning point, and you can see that these are always increasing. So this is not an absolute value, and it's not a quadratic because there's no turning point. So let's summarize this in our first question. So as we said before, the change in y is only increasing. There's no turning point. You can see that here. These are all increasing. In order to have a turning point, you would see a change in direction. So you'd see increasing here, positives, and then some negatives. We don't see that. The other thing I wanted to add is that the change in y is increasing quickly. So we're increasing here by 40. This is now over 100, and now we're changing by almost 10,000 right here. So this is getting at this second question, are the change in y values increasing or decreasing by a constant value? This would be checking the second differences. That's what I was just talking about. And we would not expect this to be quadratic, though a table could only show part of it, so it could be, so we want to look. And if we look here at the change in the second difference, you can see that this is going up by 40, this is going up by 120, and so this is not a constant change. We said down here this was a big change of more than 10,000 or about 10,000. So no, it is not increasing by a second difference. So the next question that we're being asked is there a common multiplier or a common factor for these? And so I'm actually going to erase my differences because I know that there are no common second differences. And we're going to look for a multiplier. What does this mean? This means, like, can I multiply something? So 20 times what gives me 60? And to do that, if you don't know that 20 times 3 gives you 60, you could divide that on a calculator, 60 divided by 20, and get 3. And then you could do 180 divided by 60 and see that that is also times 3. So take a look, and let's look at and see if there's a common multiplier or common factor all the way through our table. I want to show you what I'm doing on a calculator. I just pulled up, Desmos has a scientific calculator, and you can see that right here. It's just desmos.com/scientific. If you Google Desmos scientific calculator or Desmos calculator, you'll get this. It doesn't need to graph, so that's why I'm using the scientific one. So from 180 to 540, I just typed in 540 divided by 180, and you can see that the answer there is 3. So that means that this is also times 3. If I take a look at the next one and I type in, let me clear that. I have to hit enter first. If I type in 1,620 and I divide that by 540 and I hit enter, you'll see that that's also times 3. And you could do this for the rest of the table. So yes, there is a common multiplier. And notice that we're looking at the change in y values. We're looking for that delta y. And so it is times 3. So yes, it is 3 or times 3. And so looking at our table, it's already filled in. The question they asked is, when will the beach have to close? And you can see up top, it told us that it's dangerous to swim if we're over 5,000 of those microbacteria. And 5,000 would be somewhere in here, which means that after day 5, so day 6 is when our beach would have to close to do maybe some cleanup. So you have this written at the top of your page. This is our fourth type of function, the final one that we're looking at in this unit, and it's called exponential. And we can rule out why it is not linear, even though we're only increasing, which is one of the characteristics of linear. It is not increasing by a constant rate, and our rate of changes are different. These would all be different rates of change: 20 over 1, 60 over 1, 180 over 1. And then it's not absolute value because there's no turning point. It's not quadratic because it's no turning point. And it's more than that, because I know a table could only show part of it. It could only show half the graph and not get to the turning point. But again, for absolute value, you would see a constant relationship in the absolute, in the change in y and change in x. And for quadratic, you would see that the second difference is constant. And we didn't do a difference here. When we did the difference, remember, we got 40, we got 120, we were getting different values. So our second difference was not constant. And we have this constant multiplier. And when it's a factor or a multiplier, those are synonyms. We can use those together. We know that it is an exponential function. We're going to talk about those characteristics in the box below. How to identify an exponential function in a table. So one of the first things we look at is the rate of change. And to do that, we look at the change in x and the change in y. And so when we look at that, we see that it changes by a factor. So sometimes the word factor can be interchanged with multiplier. It's the same. Rate of change changes by a factor or a multiplier. Recall that our change in our rate of change is the change in y over the change in x. We are often only looking at the change in y because if our change in x is 1, the rate of change is the same number as the change in y part. So I'm putting that there as a reminder. And what you're going to be looking for when you're looking for that common factor is you're looking for, can you multiply or divide that change of y to get the next value? We are seeing in our table also that there is only increasing or decreasing. There's no turning point. Or vertex. So no turning point in your table. And finally, it's going to increase or decrease quickly. And when we write our rate of change, when we're talking about our ROC, when we're doing our practice, you are going to tell me that your rate of change is increasing. You're going to use the word increasing or decreasing, whichever it is. And it's increasing if it's multiplied by something, and it's decreasing if it's divided by something. And you're going to say by a factor of, and then you're going to give that value. So the previous example was increasing by a factor of 3.